So my dear students, I have told you earlier I will discuss the Thevenin's equivalent circuit in details and solve a circuit that you can easily solve any kind of circuits in Thevenin equivalent circuit. There is a very simple circuit, practice problem 10.8 of Fundamental of Electric Circuits, Mathing and Study Group. As you can see here, the ports A and B are removed. So you can see here A and B, the ports, that is the port of load impedance that has been removed. So when you have just remove this remove this load impedance, you have to find out the first of all the first duty is to remove. Here it has already been removed, so you have to find out the Thevenin equivalent impedance, not resistance, Thevenin equivalent impedance. So you have to see here the source, in which source are or sources are connected to the circuit. Here you can see there is a voltage source. So first of all, voltage source will be short circuited. Voltage source will be short circuited. If it is voltage source, so it will be short circuited. Voltage source, it will be short circuited. So you have to connect it together. If it is a current source, it will be open circuit. Okay, that is a major difference. Okay, now coming back to the point, that first of all we have to make a short circuit, then to find out the equivalent impedance. I will give you another lesson or another idea, that or you can say that will be a tip to make it more easier. Just first of all, make the impedance a block. This is one block, this is the number 2 block, this is the number 3 block, and just mark these blocks, okay, to find out this. Just when you have, first of all, make a solution of it. So first of all, make the voltage short circuited. Okay, I have given the short circuited. Then make a block, first block, then that will be the second block, and connect these two things. Then that will be the two terminals are here, remaining terminals, that will be the third block, and just mark this block like this. It will be Z1, that will be Z2, and that will be Z3. So Z1, Z2 and Z3 has been marked. So you have to look forward in this direction to find out the Z Thevenin, the Thevenin equivalent impedance. Okay, so while you are looking forward to this position, what can you see? These Z1 and Z2 has been short circuited. You can easily see here there is a short circuited. That means that is this part and this part has been short circuited. So did these 2 points, this point and this point, are common points. That means Z1 is parallel to Z2, and then and these 2 parallels will be series to this, and then you can find out Z Thevenin. So according to find out the Z Thevenin, you can easily say Z Thevenin is equal to that will be Z1. First of all, Z1 parallel to Z2 2, then it will be the series in Z3. So now just determine the equations like this. Z1 is equal to 6, that is impedance, so 6 plus J2 ohm, 6 plus 6 plus J2 ohms, 6 plus J2 ohms, that will be Z2 will be minus J4 ohms, 4 ohms, minus J4 ohms, and Z3 is just resistance 10 ohms. So that will be 6 plus J2 parallel minus J4, and that will be connected, that is connected to the another 10 ohms. So the final equation will be, first of all we have to find out the equation, so I have just to remove these things and then to calculate. So now you can see Z1 parallel Z2, so 6 plus J2 parallel minus J4 so as you can calculate it at your own, you can multiply these two and divided by the summation of it, then you have gotten a result. After that, finding out these things, just put onto here, and that will be plus 10 ohms after calculating these two impedances. So that will be 2, after calculating this, that will be 2.4 minus plus 3.2 J plus 10 ohms, 10 ohms. After that we will find out the impedance, total sorry, there is a mistake, simple mistake, that will be minus minus J 3.2. so the total impedance will be the Z7 will be 12.4 minus 3.2. At last we will get the total Z-Thevenin. The Z-Thevenin will be, equal to 12.4 minus J 3.2 ohms. So that will be the final result of Z-Thevenin equivalent resistance.